Lesson 11.7. Today we're going to learn how to simplify mixed expressions and complex fractions. Another word for a mixed expression when dealing with plain numbers would be a mixed number. Okay, let's recall how we changed a mixed number to an improper fraction. For example, let's take 1 and 1/2 as a mixed number, and let's rewrite that as an improper fraction. What you would do is you multiply the denominator 2 times the whole number 1, 2 times 1, and then you add the numerator 1, and then you put it over the denominator 2, okay, so that you get 3/2. Well, it's the same exact process, except that we're going to be dealing with expressions. So here's the rule. A and or plus, there is an invisible plus sign here, plus B over C equals AC plus B divided by C. Okay, so let's go ahead and apply this same rule to these mixed expressions. Okay, so we're going to take the denominator x minus 1 times 2, so I'll write it this way, 2 times x minus 1, and then we're going to add 4 plus 4 over x minus 1. Let's simplify. Distribute 2x minus 2 plus 4 over x minus 1, and one more time we simplify. 2x plus 2 over x minus 1, and of course we can factor out a 2, x plus 1 over x minus 1. And that would be your answer. Okay, let's go on and look at number 2. Again, the same process applies here. We're going to do x times 2, which is 2x. Then we'll add 5 plus 5 over the denominator x. Okay, so 2x plus 5 over x, there's really nothing we can do to simplify that. That would be your answer. Okay, so this one looks a little bit different only because it's in a different order, but it's the same basic rule. You'll take the denominator times 5y. So let's write that down, and I'll write it this way. Oh, sorry about that. 5y times 4y plus 8. And then we will add 6y plus 6y and put all of that over 4y plus 8. Okay, let's simplify. 5y times 4y is 20y squared. 5y times 8 is plus 40y, and then add 6y. Okay, let's simplify. I'm sorry, all of this is over 4y plus 8. And we'll simplify a little bit more. We have 20y squared plus 46y over 4y plus 8. Okay, we can simplify this because there's a common factor of 2, and we have 10y squared plus 13y, and then here, common factor of 2, we have 2y plus 4, and all of that is so that we can cancel out the 2's. So my simplified expression is 10y squared plus, I'm sorry, this is 23y over 2y plus 4. And that would be a simplified expression. All right, let's look at complex fractions now. A complex fraction, by definition, has one or more fractions, either in the numerator or in the denominator. And the way we simplify is by using division. So let's look at this numerical complex fraction, 2/3 over 5/8. What I want you to think about is that this means divide. So when I write this problem down, I'll do 2/3 divided by 5/8, and I recall that to divide fractions I multiply by the reciprocal, so it's really 2/3 times 8 over 5, and so I have 16 over 15, and I can keep the improper fraction just like that. Okay, let's try this one with variables. A over B over C over D. So again, I need to remember that this division bar means divide. So I'll write A over B divided by C over D, which means really A over B times D over C. And when I multiply across, I have AD over BC. And that would be my solution. All right, let's go on to number 6. Again, this division bar means you're going to divide the rational expression that's in the numerator by the rational expression in the denominator. So let's write it out. 8t squared over v divided by 4t over v cubed. What that really means is 8t squared over v times v cubed over 4t. Okay, before I multiply across, I want to cross cancel everything that I can. So this becomes v squared, that becomes a 2, that becomes a 1, this becomes a t, and this becomes a 1. Okay, so once I'm done with all that reducing and cross canceling, here I have 2tv squared over 1, or just plain 2tv squared. And that would be my quotient. And let's look at number 7. Again, let's write it as a division problem. I have g cubed h over b divided by g h cubed over b squared. And again, multiply by the reciprocal, g cubed h over b times b squared over g h cubed. All right, do a little cross canceling. G cubed becomes g squared, and g becomes a 1, b becomes a 1, b squared becomes a b, h becomes a 1, and h cubed becomes h squared. Okay, so let's multiply across. G squared b over h squared, and that would be my quotient. Okay. All right, try number 8 on your own. Well, no, just kidding. I'm going to do this one with you because it takes a little more factoring. Okay, so let's write it out. 2 over y plus 3 divided by 5 over y squared minus 9. I look at that and I recognize that as a difference of squares. So I'm going to rewrite that as y plus 3 times y minus 3. Okay, now let's write the division problem as multiplication. 2 over y plus 3 times y plus 3 times y minus 3 over 5. And then, of course, I can cross cancel y plus 3 and y plus 3. And so when I multiply, here I have 2 times y minus 3 over 5. And that would be my solution. Now number 9 you can do on your own. Pause the video, come back and check your answer. Okay, check your solution. I have 5 over 2 times a minus 7. All right, let's go to number 10 now. Number 10. Okay, so let me first write it out. I have n squared plus 7n minus 18 over n squared minus 2n plus 1 divided by n squared minus 81 over n minus 1. So I guess the first thing I need to do is I need to rewrite all of these in factored form. So let's factor this. I have n and I have n, and I need two numbers. These two are -2 and +9. Okay. These two numbers are n, and we have -1, -1. This is the difference of squares. This is n plus 9, n minus 9, and n minus 1 is already simplified. So now let's write this as a multiplication problem. So I have n minus 2 times n plus 9 over n minus 1 times n minus 1 times n minus 1 over n plus 9 times n minus 9. Okay, now let's cross cancel. N plus 9 and n plus 9, n minus 1 and n minus 1, and that's all I have. Now let's multiply across. Here I have n minus 2 over n minus 1 times n minus 9, and that's my solution. Okay, let's go over some independent practice. You're going to write each mixed expression as a rational expression. Okay, so there you have number 4, and number 10. And here you'll do some complex fractions, 1, 5, and 9. Simplify those. Alrighty, so God bless you. Have a great night, and we'll continue working tomorrow.